Hello, grade 9s. Starting from today, we will learn Unit 6. Unit 6, it's linear equations and inequalities. Let's look at what we will learn in this unit. In this unit, we will focus on two topics. The first topic is how we can model and solve problems using linear equations. The second topic is how we can explain and illustrate strategies to solve linear inequalities. Let's look at why we need to learn linear equations and inequalities. Because both of them occur in everyday situation involving ratios and rates, geometric formulas, scientific contests, and financial applications. Using the equation or inequality to solve the problem is an important problem-solving strategy. Let's look at the first lesson, 6.1, solving equations by using inverse operations. I chunked the whole lesson into two parts, so today we will talk about the first part of 6.1. In this part, we will focus on inverse operations and how we can use the inverse operations to solve equations. What's the meaning of inverse operations? Inverse operations means undo or reverse each other's results. For example, addition and subtraction are inverse operations. If I see addition, the inverse of addition is subtraction. Vice versa. If I see subtraction, I need to do addition. Multiplication and division are inverse operations as well. If I see multiplication, I need to do division inversely. If I see division, I need to do multiplication inversely. Two methods to solve the equations. The first method is inverse operations. In this method, we first build the equation, then solve the equation for the variable. The second method is called the algebraic solution. In this method, we need to isolate the variable by using the inverse operations, which is the same as reversing the operations. Of course, we will focus on algebraic solutions in this lesson. But of course, the inverse operations will help us understand why I need to solve an equation following those steps. Let's look at solving one-step linear equations first. Example 1. Solve x plus 2.4 equals 6.5. Let's start from the left side. The left side is the variable x plus 2.4. And thereby I get to the left side form, which is x plus 2.4. And this left side is equal to 6.5. Let's look at, on the left side, I do adding 2.4. When I reverse the operation, this adding 2.4 becomes subtract 2.4. So this reason, okay, in the bottom, I take the inverse operation, I minus 2.4 from 6.5. So then I get 4.1. This 4.1 is the x value. If you understand this inverse operation, then we can understand the algebraic solution very well as well. So let's look at solve x plus 2.4 equals 6.5. Here it's adding. When I solve for x, I need to take the inverse operation, just like what we explained in the inverse operations. Plus 2.4 minus 2.4, they become a zero pair. We can cancel out these two numbers. That's how we can isolate x from positive 2.4 as well. So on the left side this time, I only have x left. Then x equals 6.5 minus 2.4. This one is 4.1. Okay. Let's look at another example. In this example, you need to write an equation, then solve for the variable. It's 3 times a number is negative 3.6. If I want to translate all those words into an algebraic equation, I need to let this unknown be a variable. So let's say the unknown, the number, be n. So 3 times n equals negative 3.6. Let's look at the inverse operations first. Starting from the left side, the variable n times 3 multiplied by 3. Then I get 3n on the left side. And this 3n is equal to negative 3.6. But when I want to solve for n, I need to take the inverse operation. Look at the above operation. It's multiplication of 3. So this is the reason why I need to divide this number by 3. Negative 3.6 divided by 3 is negative 1.2. And this negative 1.2 is also the value for the unknown n. So let's look at how we can solve this equation algebraically. 3n equals negative 3.6. That's the original equation. I want to find n. I need to isolate this number 3 in front of n, which is also in the multiplication. Okay, look at multiplication. The inverse of multiplication is division. So this is the reason why I need to divide both sides by 3. 3 divided by 3 equals 1. 1 times n is the same as n equals negative 3.6 divided by 3. This is the reason why we can get negative 1.2 algebraically. So right now, let's look at how we can use the inverse operations to help us understand two-step equation solvings. Let's look at example 3. Solve 4.5 times d minus 3.2 equals negative 18.5. This equation involves 2 steps. Let's look at what are these 2 steps in the inverse operation model. Let's build the equations first. From the left side, we will follow the BADMAS to build the equation. The variable d times 4.5 first. Multiplication goes first. Then we do subtraction. So the left side is 4.5 times d first, and then subtract 3.2. And this one is the same as negative 18.5 on the right side. When we want to solve for d, we inverse the orders as well as the operations. Look at the above operation here. This one is subtract 3.2. So when I go backwards, the first step is not for multiplication. Instead, the first step is for this subtract 3.2. The inverse of subtraction of 3.2 is adding 3.2. So I add 3.2 to negative 18.5. I get negative 15.3. And this negative 15.3 is also the value for 4.5 times d. Then I look at the above operation. For this step, the above operation is multiplied by 4.5. Its inverse should be divided by 4.5. So I divided this number by 4.5, I will get negative 3.4. So negative 3.4 is the unknown d value. So if you can understand how we inverse the orders as well as the operations to find the unknown d, you will have very good sense to solve this linear equation involving two steps. I will copy the equation first. Then let's look at it. If I want to find the d value algebraically here, based on the understanding from the inverse operations, I realized I need to isolate negative 3.2 from this entire multiplication first. This reason we take the inverse operation on both sides. Subtract 3.2, I add 3.2 to both sides and cancel these two. So right now I only have 4.5 times d equals negative 18.5 plus 3.2. So this one is negative 15.3. Then I isolate 4.5 from d in the multiplication. Multiplication becomes dividing. So I divide both sides by 4.5. 4.5 divided by 4.5 is 1d, which is the same as d. Negative 15.3 divided by 4.5 is negative 3.4. So that's how I can solve the algebraic equation algebraically. Let's look at example 4. Solve r divided by 4 plus 3 equals 7.2. The first method is still to use the inverse operations. Let's build equation following the bad math first. The variable r divided by 4. Then I will get r divided by 4. Then plus 3. So the left side is r divided by 4 plus 3. And this left side is equal to 7.2. When I want to find the r value, I need to reverse the order as well as the operations. So adding 3 becomes subtracting 3. So I need to subtract 3 from 7.2 as the first step when I solve for r. So 7.2 minus 3 is 4.2. 4.2 is equal to r divided by 4. Then if I want to solve for r in this step, I look at the above operation divided by 4 becomes multiplied by 4. So 4.2 times by 4 is 16.8. So this 16.8 is also the r value. Let's summarize the operation here and use this method to solve this equation. R divided by 4 plus 3 equals 7.2 algebraically. The first step is not for dividing. The first step is get rid of adding 3 on the left side, which is also called isolating r over 4 from plus 3. So I subtract 3 from both sides. Then I canceled the 3 on the left side. On the left side, I only have r divided by 4 remained. 7.2 minus 3 is 4.2. R divided by 4, I want to get rid of this 4. So take the inverse operation. I multiply both sides by 4. So 4 divided by 4 is 1. 1r equals 4.2 times 4, 16.8. So here I want you pause the video for 5 minutes to 10 minutes. I hope that you guys can follow what we explained in 4 examples and solve all the equations. Then come back to the video and check the answers with mine. Let's look at example 6. This is an easy problem solving. 7% of a number is 56.7. First, I need to translate all those words into an algebraic equation. 7% means 7%. I use the mathematical numbers and the symbols to represent 7%. Of a number, you guys learned this one in Math 8. In mathematics, of is the same as multiplication. So 7% times a number. Let the number be x. So 7% times x is 56.7. What is 7%? 7% means 7 out of 100. If I want to convert this one to the decimal, you can change this one to 0.07. So this equation is the same as 0.07 times x equals 56.7. Let's solve the equation by using the inverse operation. Multiplication becomes dividing. So I divide both sides by 0.07. 0.07 divided by 0.07 equals 1x. This 1x equals 56.7 divided by 0.07. So the answer is 810. That's how I can find the x value. Let's verify the solution. If we want to verify the solution, that means I plug this 810 back into the equation for x. This is the x value. So 0.07 times 810 equals what? So let's use the calculator to look at if this answer is the same as the right side, which is 56.7. If this one can make the right side true, we say this one, 810, is the solution of the equation. Okay, so right now, I want you guys to use all the inverse operations to solve those equations algebraically. 8.4 equals 1.2 times b. If you don't like this way of demonstrating the equation, you can convert this one to 1.2b equals 8.4. You can just swap both of the sides simply. 1.2 times b. The inverse of operation of this multiplication should be divide both sides by 1.2. So after you divide both sides by 1.2, on the left side, you only have b left. 8.4 divided by 1.2, it's 7. So the solution of this equation is b equals 7. Let's look at k divided by 3 equals negative 1.5. In the original equation, the operation is divide k by 3. So I need to take the inverse if I want to solve for k. I multiply both sides by 3. 3 divided by 3 is 1. 1k, which is the same as k, equals negative 1.5 times 3, negative 4.5. Let's look at how we can solve this two-step equation. If you don't like this way of demonstrating the equation, you can swap both of the sides. It's the same as 3b minus 12.5 equals 10.5. The left side, if I follow the better math, I do multiplication first, then subtract 12.5. But when I solve the equation, I need to reverse the order as well as the operations. So I add 12.5 to both sides first. Cancel the positive and the negative ones. So I only have 3b left on the left side. 10.5 plus 12.5. This one becomes 23. Then 3 times b equals 23. I only need to divide both sides by 3 because the inverse of multiplication is dividing. So b equals 23 divided by 3, which is 7 2/3. Let's look at 1/4 times r. Minus 2 equals 4. I hope that you guys can understand 1/4 times r is the same as r divided by 4 minus 2 equals 4. So here on the left side, we have dividing first, then subtract 2. So if I want to solve for r, I reverse the order. I add 2 to both sides first and cancel these two numbers. Then I have r divided by 4 equals 6. The inverse of the dividing is multiplication. I multiply both sides by 4. So then I will have r left equals 24. Okay, let's look at how we can solve E. 56 divided by 8 equals negative 1.5. This time, the variable a is in the denominator. I will do the same thing. 56 divided by a, it's dividing. The inverse of dividing is multiplication. So I multiply the denominator a on both sides first. Then a divided by a becomes 1. On the left side, I only have 56 left equals negative 1.5 a. So this negative 1.5 a equals 56. You can just swap both of the sides simply. It's multiplication. The inverse of the multiplication is division. So then I divide both sides by negative 1.5 in order to isolate the number in front of a. Negative 1.5 divided by negative 1.5 is 1a equals 56 divided by negative 1.5. And this answer is negative 112 divided by 3. If you guys don't like the fraction, you can keep this answer in the decimal. You can use the calculator to help you find this decimal. So this decimal is around negative 37.3. If you guys want to keep the repeating bar on number 3, you can still keep the equal sign here. The last one, let's look at how we can solve for n in this case. Let's look at how we can build the equation on the left side first. It's 2 minus n divided by 3. And this one is the same as negative n divided by 3 plus 2 equals 2.8. So then you will see I have plus 2 first. I want to isolate this plus 2 from the entire division. So I subtract 2 from both sides. Then I will have negative n divided by 3 equals 0.8. This time I have a negative sign in front of this division. We learned this one in Unit 3 already. In a fraction, this negative sign can be taken as the negative sign for the variable or the negative sign for the number in the denominator. So I prefer to put the negative sign in front of the number because the variable n becomes 1n. So this one actually is the same as n divided by negative 3 equals 0.8. It's dividing. The inverse of division is multiplication. So I multiply both sides by negative 3. Negative 3 divided by negative 3, you cancel them out. So it's 1n. 1n equals 0.8 times negative 3. It's negative 2.4.